Hey everyone. Today I thought I'd talk about the incremental parser and two important optimizations I've done in the last few days and I'm working on now. Welcome everyone. I just want to say thank you for everyone who's put stuff in the issues database. Let's get over here. Had quite a few people obviously trying out 10x and finding minor bugs and some major bugs and adding them in, and that's really helpful for me. Any kind of crash bugs I jump on straight away, but other bugs at the moment I'm not ignoring them. I look at every one, but for now I'm still working on the parser, and I'm really looking forward to actually getting onto some of these because they'll make 10x. They're kind of, a lot of them are quality of life things, just little things that just make the editor so much better to use. And yeah, it's going to be really fun to work on them. And most of them are fairly easy, which would be nice after working on a parser for so long, which is challenging. I still need to prioritize some of these. So the default priority I give them is priority 3, which just is what I give everything except for stuff I think I should work on soon. Priority 2, priority 1 is a crash bug, but that never gets a priority because I usually fix them straight away. So yeah, anyway, thank you for that, and keep them coming in, and I will get to them eventually. In the background, I'm just running my stress test, testing the latest optimization that I'll be talking about today. It seems pretty good. It's working well. It's not using up tons of memory or CPU. CPU is about 10%. Which is 1 and a bit cores, which is fine. Much better than 100% it was before at times, so that's pretty good. I think I'll just leave that running for now. Yeah, it's kind of fun to watch, isn't it? Going that quickly. It's just adding characters every frame, basically. It's kind of hypnotic to watch sometimes. But anyway, that's going well. Right, what was I going to talk about first? Let's get rid of that because that's a little bit distracting in the background. So yes, the incremental parser. So obviously the big thing that makes this different from writing a compiler is obviously it's an editor and you can change the code, and it needs to update incrementally just that bit of code you changed and keep everything working together, keep everything updated basically. So it's going to be tricky to explain these without giving you some background on how the parser works. I mean, hopefully if you've seen some of the earlier streams, you'll have a good idea of how the 10x parser works. But the problem is, so let's open up 10x. Not the stress test, 10x. Let's make it big so you can see. Let's go to the header. Okay, so basically whenever you edit code, it's got to update whatever it's parsed and then update anything that's referencing it. So for example, I've got class 10x main here. If I make a change to that, as you can see, it's updated instantly, this, because it knows they're the same thing. And if I change it back, hopefully, it should come back. Oh, that's weird. That hasn't come back. Okay, that's the first bug. Anyway. I probably need to explain a bit more the way it works before I actually get onto the optimization. Let's open it up in Okay, I always find it easier explaining stuff when I can point to stuff visually. So this isn't showing anything complex. Anyone who's thought about a parser will understand this. Basically, it just parses the code, turns it into tokens, which I've shown by these yellow boxes, and then creates a tree, as you'd imagine, from the code that it's parsing. So namespace will have a child called function, which will have a child called test. All fairly simple. And all of these, I've called these defs. You could call them symbols, or I don't know. Def isn't a very good word for definition, but nothing to do with the preprocessor. I've just called them defs. And each def has a unique ID, which is just an incrementing int, which I put in brackets here for each one. And then as I tokenize it, each token will have an ID in it to say what it is referencing. So for example here, actually that's not a good example because that, if I had, say, another line, test equals 2, so this would have, oh god, it's not good, hang on. This would have an ID of 2 because it's pointing to test, obviously. It's actually pointing to this. And obviously when I change this test, it's got to update here. So if I change that to test 1, that would have to invalidate this. So that's it. I'm talking about the tokens now and the ID in the tokens. And that's the whole problem, basically. And the other problem is when you're editing code, it's got to work out what you need to actually re-parse. Now, some parsers I expect will just re-parse the entire file on every change you make, or every second or so, they'll just re-parse the file. 10x doesn't do that. 10x will, if you change just one line, it will literally just re-parse that one line. In reality, it usually does 2 or 3 lines. But it parses the minimum amount possible and then makes updates based on that. And that makes it quite tricky to work with, obviously, because I've got to keep the tokens in the source code in sync with the tree that I'm building up, that I've built up already as I've parsed the file the first time. And then I've also got to keep it in sync with anything that references it in the code later on. So I've got to update things that reference it if I change the name of stuff. So there's a lot of moving parts, and it's proved one of the trickiest parts of the parser, actually. So let's go back to 10x. Now, if I make a change like adding a variable here, I can't usually just re-parse one line, because if I'm typing here and I've typed, say, if I've just typed the int with no semicolon or anything, then it could be, for all the parser knows, it could be part of this function definition. So I would really need to re-parse that as well, which then means I've got to re-parse the entire function, which then means I've got to re-parse all of that. So the way it works, I have a few sort of heuristics to work out what to parse. The first one is that I literally just look for the next semicolon or close brace. So from example here, if I just type int, it'll go down looking for the next semicolon, which is the end of a statement. That's basically what I'm after, the end of a statement. So then I know that I can parse what's highlighted here and capture anything that's in the later statement. So if I had finished writing that and I've typed the semicolon, it will just parse to the end of the semicolon, and it won't re-parse this function, which is nice. So it's literally just parsing whatever it needs to parse. But obviously, if I did have to, in this example, reparse this function here, these lines, the parser will then say, well, okay, I'm parsing this, which I know is a function and it has a scope. So I need to expand to the rest of the scope, because if I change this function, I might be changing it from a member to a non-member or changing its arguments, whatever. So I need to reparse the entire function and everything in it. So as you can imagine, you've got this def tree here, and oh, can you see my mouse? It seems to have disappeared. Oh, it's just the paint on there. That's a shame. Oh well. So yeah, it's got to update this tree as it's parsing, and say for example I change something in the middle of this, like I rename, say, Noom account here. It's got to work out where that is in this tree, because it might be one of the children, and I've got to work out which index it is and delete that node and then parse it and then re-add whatever new nodes that I find. And the way I currently do that is I literally just, because remember all of these keywords have an ID associated with them to say what they point to. So I just literally delete any of these nodes in the tree that correspond to things I'm reparsing, which is simple enough. And then I will parse it, and then I'll find out, what new things. And usually it won't be anything new. Because, I mean, if I say just add a space to the end of that means it's got to reparse the entire thing, but nothing has actually changed. So it's going to go through, delete the nodes from the tree, and then parse it, and then think, oh, there's a new variable called process account. It didn't currently know that it was the same node or anything. It would just literally create a new node, a new ID, and add that to the tree, which hasn't really been a problem because it's not fast. It's really fast. Sorry, it's not slow. It's very fast to actually reparse this because it's literally just parsing a few lines. I mean, that's done in no time at all. So that hasn't been a problem. The problem has been that, say if I just add a space to the end of this function, it's reparsing this function, then anywhere that calls that function has to then be updated because it might be invalidated or renamed or arguments might have changed or something. So it's got to go through the entire code base and find any references to that and update them. And that has proven to be quite slow. So if you've used 10x, sometimes you'll notice that the CPU, it will go up quite a lot. And that usually happens, you might notice on shutdown when 10x will take like 2 minutes to shut down, and then you'll get a crash dump because of a shutdown timeout crash that I put in there. And what's been happening is that lots and lots of changes have been backing up because it can't get through them fast enough. And it has to go through all those changes and process them before it can shut down. And that can happen for a number of reasons. For example, if you change a class like your string class, which is used absolutely everywhere, it might have to update half the code base to do that. And so the changes, I've seen like tens of thousands of changes waiting to be processed in these crash dumps. The other thing that can cause it is if a file changes externally outside 10x, because when that happens, 10x has to reparse the entire file. Now I could maybe try and detect the changes and only reparse the changed bits, which often isn't very much, but that would require writing a whole diffing tool, which it's quite a big job and there's no real need to, because parsing a whole file only takes like a few milliseconds or 10 milliseconds or something. So yeah, when a file changes externally, I just reparse the entire file. And like I said, often nothing has changed, or just a few bits of code have been added or removed or whatever. But obviously, if you, like this file, which is huge, if I reparse that entire file, not only do I have to do that, which takes like 10 milliseconds, I have to go up and update every single thing in the code base that calls these functions. And obviously that can be a lot. And if you're typing away and changing lots of code, every key you're typing is adding another thing to the queue to be processed in the entire code base. And as you can imagine, that can add up pretty quickly if you're changing code a lot. So anyway, that's the problem. If you've got a handle on that now. The solution, let's go back to my notes. Talked about that. So what I was doing to keep these references in sync. So what I mean by reference is a token has an ID on it. Sorry, here has an ID on it that references something in the tree. And it's probably better. Hopefully you see it now. Oh, it doesn't seem to be showing it on the screen. Oh, there we go. Yeah, so what it was doing was when it first worked out, like I said, what it needs to reparse, then it would go through the tokens, finding the IDs of the defs or the nodes in the tree, and then delete those nodes there and then from the tree. Let's go back. And as it deleted the nodes, it would add it to a global list of things that needed to be reparsed, which is fine. So it would add an event saying clear any tokens with this ID from the entire code base. And that's fine, that worked. And then when it comes to parse whatever's changed, it will add a new node for the new stuff, and then add another event saying these are all things that need to be checked again. And it would do that by name, because obviously this is a new ID, so nothing in the code base will be referencing it yet. So I don't know what is referencing it. So what I actually do is I go through all keywords. Say if I've added a variable called test, I go through all keywords called test and see if they're invalidated, and if they are, I'll do a go to def on them to see if it takes me to this new thing, and then I'll obviously fill it in and update it. And that's fine, that all worked, but there were a few bugs with it. The main bug, which I fixed a couple of months ago, I think, was that these two lists were getting out of sync, because everything pretty much in 10x is async and threaded. And the two lists were getting out of sync. So it was sometimes, because as you imagine as you're typing, as you type a key, it goes, okay, clear that, and then add one for the new one, type another key, it says, oh, clear that, add it to the new one, as it's constantly reparsing. And the clear and the reparse would sometimes get reversed. So it would do a reparse first on all the variables called test, and then it would do a clear on test. And you'd end up with missing references. And until I worked that out, that was a real problem, real difficult one to track down, because it was real subtle timing based on. So my fix for that was to serialize the events. So I created just an event class, which could either be a clear or it could be a reparse of the variable. So they would always be done in sync. And that got rid of the problem, which was fine, but it wasn't fast, because as you can imagine, as you're typing, it's constantly creating all these events, clear test, clear test, clear test. And it's, like I was saying, they would get backed up, and 10x would just sit there churning through all these events, which were pretty much useless because they were all things that had happened in the past. So what I did, which seems obvious now in hindsight, for some reason I couldn't see it originally, was that I just unified those two events. So instead of saying clear it when I delete the node, and then having another event saying, okay, reparse all the things called whatever it is, test, whatever, that if I've created a new thing called test, reparse the entire code base to find anything called test and then point it at my new thing. I literally just combined them into one event, and the event has the ID of either the new thing I've created, which I just ignore, or the old thing which I've deleted, and the name of the thing, which if if I'm deleting something, I just ignore the name, because if I'm deleting something, I just go through and delete everything with that ID. That's fine. I know that. I know the references for that ID, so I just clear them. And if I'm creating a new thing, like I said, I use the name of it and say, okay, anything of that name that hasn't got a reference yet, I check it and see if it's pointing to my new thing. So I created one event with those two things in it, the name and the ID. And basically, it's just one if statement. And it just says, okay, if I've got something that matches the ID, which will be in the case if I'm deleting something, then I'll re-parse it. I don't have to clear it. I can just re-parse it and say, okay, what do you point to? Because if I haven't added the new thing yet, it will just point to nothing. That's fine. That's the same as clearing it. And if that's not the case, and I just find something that matches the name instead, then I'll just re-parse it. So in either case, it's doing exactly the same thing. It's just doing a goToDef on the keyword. And what that means is I don't have to worry about the sync problem anymore. I don't have to worry about the clear getting out of sync with the re-parse, because they're the same thing. And what that means is I can just have one big list and update it periodically, every few frames or something. And every time something changes, I just add it to the list if it's not there already. If it's there already, and I've already said you need to re-parse this thing, I don't add it, obviously. And that makes it really, really fast, because it's not adding thousands and thousands of events for every single change you make. When I realised this, it was such a light bulb moment. And I thought, well, obviously, yeah, why was I thinking I had to clear it and then re-parse it? Why don't I just do it all in one? So that one simple if statement allowed me to do this. And it's just cut down all the CPU usage. So as you can see, this is running the test for it, and with any luck, the CPU is still reasonable, like 10%, which is great. So that means the parser is keeping up with all these incredibly fast edits. So I'm really pleased with that. I'll see if I can find you the if, because it's kind of odd. Hang on. Where is it? So the start re-parse references task obviously is on another thread. And okay, here we go. So first of all, I just create a string hash set, a new string hash set class, which I think I talked about last time. So I get a list. These are all the references that are changed, which could be quite a few. Like I said, if it's reparsing an entire file, it could be a few hundred in there. And each of these reparse references has a def, which is basically the ID I talked about, def ref, and the name of the thing. So in the case, like I said, where it's deleting it, it will have the def ID, which I know specifically what things to clear or try and reparse. And if it's a new thing, it will have the name, which I know means to reparse anything of that name, we get the def of anything of that name. So it literally just says, well, if it's the ID, then I know to reparse it, try and reparse it, which will clear it if it's not there yet or at all. Or if it's the name contains, the name's map contains the name of the keyword, then I'll try reparsing it. But only if the reference is invalid. So if I've got a keyword where the reference is invalid and it's a name of the thing I just added, let's try and get the def of it. And that's what that does. And that's what you see that's what happened. That's what makes you see that's when you see it change color, you know it's got the right def ID, because that's what runs the syntax highlighting. So that was my first optimization, which is already out there. Actually, I released it a few days ago, and it seems to be working quite nicely. The second optimization, let's go back to the image. So as I was saying, as it's going through and parsing the file, and it's creating the def tree, like I was saying, often not much changes, and I've got to parse an entire function and everything in it, even though that nothing has really changed, just because of one, character difference or something. And it seems very wasteful to create to first delete the node and then create a node, even if it's something that already exists and carries on existing. Because each time I create a node, I update the ID, which means I have to update anything that references it. And my original plan was always to reuse these nodes. So if I'm reparsing something that hasn't changed, ideally I want to be reusing the node and reusing the ID, because then that means I don't have to update everything that references it, or allocate a load of stuff on the heap for all these nodes. And when I originally started writing the parser, I tried to do that, and I just could not get it to work. There were so many little subtleties about the indices and the order of this node tree, and all the subtle different things that could change when you're writing code and you haven't finished writing a statement yet, and it's kind of constantly trying to parse it and update this tree at the same time. It was chaos, and in the end I just decided, no, concentrate on the parser, get the parser working first, even if you have to reparse the entire file, and then think about this, which is basically an optimization later, which is what I did, and it's worked pretty well. So I'm just looking at questions. I should probably take a breath and stop talking for a while. This looks great. Any plans for macOS version? Yep, definitely one day. It's on the plans. GTN, I'm a bit confused by your graph. Do you keep track of the variables' values? No, the parser doesn't know anything about the values here. So when it, for example, parses this int test equals 1, all it knows is there's a variable called test, and it is of type int, and it pretty much ignores everything else up to, after that. So it's not like a compiler. It doesn't have to know all the information a compiler would need to know. If I had a more complex statement, like it's doing a function call, then the parser, like I said, it knows that it's a variable called test of type int, and that's all it needs to know. And then later on, when I do the def resolving, I look through all the keywords and say, what is this? What is this? And I'll get to here and say, what is this? And then hopefully I'll find a function call, get my value somewhere, grab the ID of that, and then stick the ID in here so I know what this points to. And then if I've got something later on, I'll find this keyword, say, what does that point to? Find this and give it that ID. So everything points to something, and I don't actually need to know everything about the full statement of it. So hopefully that kind of makes sense. It's literally just, this is what you might see in the class tree in Visual Studio or something. It's just showing a hierarchical thing of the different types and classes, different variables and classes and stuff. So, for example, if at the start of the function you have test equals 1, a few lines down, you also have test equals 2. Do you keep what values test has throughout the function? Yeah, so yeah, like I said, I don't store the values at all. The parser has no idea what the value is. It's not like a debugger or a compiler or anything. So another question, what happens if your change has a lot of impact, like changing a macro? Is it possible to still go down the incremental route for this kind of change? Macros are a little bit different, and that kind of ties into the preprocessor, which I might talk about later. But yeah, like I was saying, if you've yeah, okay, yeah, I'll talk a little bit about that. So the preprocessor, as I was talking about, do watch my last stream if you want to find out more about that, because I talk about it a lot more detail. But basically, for the preprocessor, I will pre-process all of the preprocessor lines in the file. So, for example, if I change string, no, that's not a good example. I haven't really got many macros in my code, to be honest. But basically, it will go through the included files, pull out all the preprocessor macros and definitions for this file that I'm currently parsing. And if any of those have changed, it will actually re-parse the entire file. Because often macros have a big effect, which is what you're getting at, I think, on the code. And you can't really do that incrementally so much. So I will re-parse the entire file if a define or a macro, like if something is if-def out, I obviously need to re-parse everything because they can have some big impacts. So yeah, changing macros is a little bit more expensive, but hopefully that's done less often than writing code. And it is a bit of a problem, but with this optimization I'm talking about now, it should be much less of a problem to re-parse the entire file. So what I do now is, say I'm parsing this function. Hang on a minute. Say I'm re-parsing this function, and I have to re-parse everything in it, which includes like local variables like this test. I won't delete the node from the tree when I work out, okay, I'm re-parsing this entire function. Instead of deleting everything from the tree and starting again, I just mark everything as removed, but I don't actually remove it, and I don't remove it from the main central, what I call the database of the entire workspace. I don't update any references to it because it might come back. So anything that's referencing it will still carry on referencing the same ID, and I just mark it as deleted. And then when I re-parse, and I'm parsing, say, this int test line, I'll first check the parent node, because I've always got the parent node of whatever I'm parsing, which in this case is the function, called function. And I'll check the parent to see if I've got a node which exactly matches. So everything in the node has to match for it to be the same thing. And then I just reinstate it. So I'll take off that marked for deletion, and everything just stays as it was. So I've got exactly the same thing as I had before, but I've just reused the node, which, you know, it sounds obvious, and like I said, that's what I tried to do originally, but there are lots and lots of subtle things that make that difficult, especially if you imagine you're adding in new variables before or after, or changing the order of the code, copying and pasting stuff. There are lots of little things that can go wrong with keeping this tree in sync. What I would love to do is, as you're typing to have a visual display of this tree and what it's doing, which hopefully I will one day. And then you can see what it's adding, what it's removing, what it's deleting, and all the references as they update. Question, does clicking or scrolling affect incremental parsing? I've seen colours change after doing those. Might be a bug. Yeah, it shouldn't change. I mean, definitely scrolling should not affect the parser at all because it won't be doing anything. The parser literally only runs as you change code. But I think maybe what that was before I made these two optimizations, it was doing a lot of incremental parsing in the background. The parser was kind of trying to keep up. And that's maybe why you saw the flickering as it was doing that. And as you can see in my stress test, it's pretty stable. You can't see any flickering or anything. So I'm hoping that's fixed. Let me know if you still see that. So yeah, clicking shouldn't affect the parser either. Sometimes when you do a go-to definition on something, it will actually re-resolve it. So if for some reason the parser has lost what it's pointing to, or this is pointing to an old node in the tree that doesn't exist anymore, when you do go-to definition, it will actually ignore everything that's in the cache, because I cache pretty much everything. It'll ignore that and really try and work out what it is again. So sometimes you can see the parser kind of fix itself as you do like control click or go to definition on something. So sometimes you can see something there, but in general, it should only run the parser when you're actually changing code. There was a bug in the preprocessor build, I think, where if you edited a line before a preprocessor statement, it would include the preprocessor statement in your edit, even though you hadn't changed it. And then, like I was saying, when the preprocessor statement changes, it reparses the entire file. And that was causing some flickering. But I'm hoping that will go away with these optimizations. Is that fixing the preprocessor build? The first of these optimizations that I was talking about is in the preprocessor build now. Yes, it is. But the second one isn't. I haven't released the second one yet. I'm hoping I'll do that later today after this stream, because it's looking pretty solid and working well. So as I was saying, now that it can reuse nodes, I can tell it to reparse the entire file. And nothing should actually change. And I've tested that, stuck some breakpoints in, and it does exactly what it's supposed to do. It first marks all the node tree as removed. Then as it parses stuff, if it's the same, it reuses the node and nothing actually changes, and it doesn't have to update any references. So it should be this second optimization should be a real game changer on the CPU usage of 10x. So you shouldn't see it spiking or going to 100% while you're working at all anymore. So that's why I'm pretty excited about this change. Still getting used to this epic pen thing, which is really useful. Obviously I can't click on anything when it's on. So yeah, hopefully that made some sense. These things are kind of hard to explain without knowing exactly how it all works in the first place. So hopefully that made some sense to you, and hopefully you'll see the difference in 10x when you're working, and like I said, when you're shutting down, you won't have any of those hangs anymore when it shuts down. The main reason I needed to do this was because of the preprocessor build. Because like I was saying, when you change the macros or defines, it will be reparsing the entire file. So I needed it to be quick to do that. And the other reason is when you change config or platform, it's going to have to do a re-parse, because obviously a lot of stuff can change in the code when you change configuration. Lots of defines will change. So rather than incrementally update in that case, which is probably too difficult to work out what's changed and too complicated, and often when you change config, a lot of stuff changes. So you're probably better off just reparsing the entire thing anyway. And that's what I've been working on as well on the preprocessor branch, a re-parse option. It's something that long-term users of 10x will be cheering about probably, because they won't have to go and manually delete the parser cache anymore, which is a real pain. Because at the moment, the only way to get the parser to re-parse is to close down 10x, delete the parser cache, and start up again, and then it will regenerate it. And there have been a few things where that's been necessary. So I've now, I don't know if I can show you in the preprocessor branch. Come on, Visual Studio. Oh, that's odd. Where's that gone then? Maybe I reverted it. Maybe I shelved it. Let's try recompiling. But anyway, basically I added a re-parse file option and a re-parse everything option, which will be in the parser menu. I don't know where it's gone now, but I did put it there. And the nice thing is, because I've done that second optimization with the node tree, so it reuses the nodes, when you tell it to do a re-parse, it will actually pretty much be reusing everything except for the stuff that's changed. So if I change config, most stuff hasn't changed probably, and it'll reuse nodes. So because as you probably know, 10x currently uses up a ton of memory, and if I just did a re-parse in the background, it would use up twice the amount of memory, which is not feasible at the moment. But the nice thing is now it will reuse most of the stuff that hasn't changed, and it won't create a ton of extra memory, and it's much faster because it doesn't have to do loads of allocations. So it's kind of reparsing over the top of what's already there, which should help a lot. I'm just curious as to where those menu items have gone. No, they've gone. Okay, that's something I need to look at. Anyway, it's not really that important. Yeah, so I think that pretty much covers it. Like I said, I'll get the new build out maybe later today or maybe Monday now, we'll see. But hopefully soon, and then you can try it out and see how you get on. So yeah, after that new build, do let me know if you see the CPU spiking loads as you're editing code or as you're shutting down 10x. And hopefully we've got that fixed now. So question statement, an option to use all preprocessor definitions from all configs would be cool, as I tend not to switch configs that much when editing platform code. Yeah, could add that. That's an interesting idea. Someone else has already asked for go-to definition in defined out sections of code, which is also useful. I don't think I've got any if-def out code here. But anyway, as you've probably seen in the preprocessor build, it's all grayed out if it's if-def'd out. And the parser currently doesn't actually parse it at all. So it's literally just grayed out and you've got no help or nothing on there. I can probably enable the go-to definition on defined out code. But it's an interesting idea having an option to just put it back to how it was basically before the preprocessor. But unfortunately that will break stuff, because if you've got a class, defined in an if-def, and it's also defined in the else, then the parser doesn't know which one to choose. So it's a little bit tricky, because you'd have to, if it's if-def'd out, you'd have to do a parse on that code, but then somehow mark it as not as important as the code that's defined in. But we'll see. Anyway, I'll see what I can do. I'll definitely add the go-to definition on if-def'd out code, because I think that will be fairly easy to add in. Usually I get around to it in Visual Studio because it does such a terrible job at identifying when it should be grayed out, but yours does it correctly. Oh wow, that's really good to hear. That's good to hear the preprocessor is working. And the other thing is, in 10x you'll be able to change configs much quicker. You won't have this horrible long pause when you change configurations while it's doing whatever it's doing. Although when you change configs, it will do a re-parse in the background of the entire project. So it won't be instantaneous. Well, you can change instantaneously and start editing code, because there'll be no lockup of the UI or anything. But it might take a while for the parser to finish in the background. I was also thinking of, when you change configs, to actually cache that. So I could change the cache so that it works per config, and have a cache file per configuration. So when you change configs, it would just load in that cache, which would be a lot quicker. But at the moment, the caches are pretty huge, so I don't want to take up all your disk space on loads and loads of caches. But we'll see. Once I squash memory down, which I'm hoping to start soon, then it might be feasible to have a cache per config, and then it'll be much quicker switching from one to the other. Yeah, that's good. So, yeah, that's that. Seems to be working pretty well still. I sometimes leave this running for days and just see if it catches any bugs. It's really good at finding those weird edge cases. So that bug a few people found with the memory leak in the preprocessor build is fixed now, so you shouldn't see that again. It was basically, there was a bug in the preprocessor where it would parse something and then think it had to, as it was updating these references that I've been talking about today, it was thinking it had to re-parse the preprocessor lines, and there was a bug in there that meant it would carry on. You'd make one change and it would carry on parsing it, and it wasn't actually a memory leak technically, because it was just re-parsing so quickly constantly. It was creating loads and loads of events to update, like the syntax highlighting, and it couldn't keep up. So it was generating more events than it could handle, and memory was just going like that, and it was leaking about a gig every 5 seconds or something crazy on big projects. So anyway, that's fixed now. And those of you who are on the preprocessor build, do let me know how you're getting on, because if we haven't found any problems with it, I'll probably be making that live early next week sometime. Well, first what I'll do is I'll integrate these changes I'm talking about today into that build, and fingers crossed there'll be no conflicts, or it won't cause any more problems. And then if that's all good, then I'll make the preprocessor build live and we can all start using it. And then I can get on to other stuff, nice, easy UI problems that I'm looking forward to fixing. Hopefully make 10x even nicer to use. So yeah, I think that's pretty much it from me, unless anyone's got any more questions. Yep, no problem. And I'll see everyone next time, probably in, like I said, another couple of weeks. And hopefully some new different stuff to talk about when I've finished all this parser stuff, which is going to be really exciting. I'm really looking forward to getting on to new stuff again. So yeah, take care and enjoy using 10x, and I'll see you next time.